right. So it's Cisco Saturday, and today we're going to be working on STP and FHRP synchronization. So at a very basic level, what does STP and FHRP mean, right? Like, what are these acronyms? And I know you guys love acronyms, so we're going to break it down a little bit. STP stands for Spanning Tree Protocol, and FHRP stands for First Hop Redundancy Protocol. So FHRP is sort of like a suite of protocols, if you will. It contains HSRP, which stands for Hot Standby Router Protocol. It is a Cisco proprietary protocol. Go Cisco. We love Cisco over here, right? And we have VRRP, which stands for Virtual Router Redundancy Protocol. And that is an industry standard FHRP. And then we have GLBP, which is also Cisco proprietary, and it stands for Gateway Load Balancing Protocol, which helps us to load balance traffic, if you will. And I'm not even gonna go further than that, right? But first hop redundancy protocols allow for router redundancy, right? You have more than one router acting as an active and a standby router. They work in conjunction to maximize uptime, right? So if one router goes down, the standby router becomes the active router and service resumes as normal, right? So where does STP come in? Why do we want to synchronize STP and FHRP? Well, the reason we want to do that is to allow for a direct path from the host to the default gateway. And by the way, this lab was essentially inspired by Jeremy McDowell, Jeremy's IT lab. This is something that I used to have and still do have some sort of not trouble understanding. I totally understand it. I'm just here to practice the configuration and to also explain to you the basic concepts, because this is CCNA material and I'm a CCNA and I'm working on, getting to the next level through Security Plus and CCNP. So I thought that I would brush up on this, especially because I am now in the IT field and I'm working on a project, a big networking project, which I'm super excited for. So I thought that I would go over the two-tier system network topology right here. Collapse core is another name for it. CCNA stuff, make sure that you know that, right? And so again, we want to synchronize STP and FHRP. We're going to be using HSRP here because this is Cisco, right? Go Cisco, and it's Cisco Saturday. So yeah, of course we're going to be using HSRP. And we're going to essentially synchronize the two. And again, the reason why we want to do that is to allow for a direct path from the host to the default gateway, right? So let's say that in VLAN 10, we have D switch 1, distribution switch 1, as the root bridge. We want PC1. It's the root bridge, and it's also the active router for the HSRP in VLAN 10. We want this PC right here to have the maximum efficient path to the default gateway and therefore out to the internet, right? So it's the root bridge and it's also the active router in the HSRP, and it'll just go like this, go right up, right? It doesn't sound like that, but probably sounds a lot cooler inside the wiring if it's making any sound at all, right? So it goes straight up and that's it, right? If D switch 2 was the active router, right, for the HSRP, it would have to traverse, I believe, through this path. It would go to the switch, and then it'll go this way, and then it'd have to go this way, and then reach the default gateway, right? Because the default gateway is currently D switch 1, and we want it to go straight up that way. But if it wasn't synchronized, it would have to take a less efficient path, right? At least that's how I'm understanding it. So this lab allows for us to get maximum uptime and maximum path efficiency with regard to data being sent from these two hosts, right? Very simple. Very simple with regard to how this lab is set up. This is very nice and neat. And again, I'm in the field now, and I'm seeing how all of this stuff is not nicely and neatly packaged. It can be a mess, right? It can be a total mess, especially if the last engineer left it a mess. No blueprints, no diagrams, no nothing like that. Yeah, it can get crazy. So this helps us to organize our thoughts behind the protocols and the applications behind it, right? So what are we trying to accomplish, right? Let's get into it. So for VLAN 10, we want D switch 1 as the HSRP active and the STP root. D switch 2 is going to be the HSRP standby and the STP secondary root. And for VLAN 20, we want D switch 2 as the HSRP active and the STP root, and D switch 1 as the HSRP standby and the STP secondary root, right? And then we're just going to take it step by step. I'm actually going to upload this to Google Drive. It's linked in my description. This whole Packet Tracer Lab is linked in the description, and you can find it there. I put the basic commands on the right, and I put the pretty much the walkthrough here. I mean, I could have left it blank, but I didn't. I mean, when you're working on these labs, if you decide to download my lab, the answer's already here, but ideally you should try to replicate this lab on your own without the answers, right? So let's get into it. So for step 1, let me make sure that you guys can see it. I increased the font before I started up so that you guys can see. So for D switch 1, let's check its STP status, right, with regard to root, secondary, and VLAN 10, right? So the first thing we're gonna do is we are going to show spanning tree, VLAN 10. So let's look at this show command. Show commands are very important because you need to know how to configure and verify concepts in the when to become a CCNA, right? So show commands are very powerful, and we see here that this is not the root bridge. It's absolutely not the root bridge. Now let's check for VLAN 20. It is not the root bridge, right? So excuse me, the first thing we need to do is we need to make D switch 1 the root bridge for VLAN 10, and then after that we're going to make D switch 1 the secondary root for VLAN 20, right? Because we want D switch 2 to be the root for VLAN 20, right? So let's work through that right now. And we conveniently have the commands on our left, right? So spanning tree, VLAN 10 root primary, right? And then we're gonna have spanning tree, VLAN 20 root secondary. Right now, let's just look at the show command and let's see what's going on. It's probably got to settle. Wait, nope. There we go. Now we have D switch 1 as the root bridge, right? So we're good to go with that. And you're gonna see me save periodically because For some reason, Packet Tracer crashes on me. Also, I forgot to point this out before, but this show command actually shows you the port roles and the states that they're in, the corresponding states that they're in. They show the port ID and all of that stuff, right? So we see that at the time that I issued this show command, this port right here is in the learning state, which is a transitory state. This one is in a forwarding state, which these are more, static solid states, right? So let's check again. So now, since this is the root of VLAN 10, all of the ports are designated ports, right? Because all ports on a root bridge are designated ports, right? And they all forward. Now let's look at VLAN 20. This is the root bridge, right? Despite the fact that we put the spanning tree VLAN 20 root secondary, and despite the fact that we configured dswitch 1 as the secondary via this command right here, it's showing up as the root bridge for that VLAN as well. And that's because of this priority. This priority is definitely lower than this switch or any other switch in this network. And as we know how STP works, it's going to allow it to be the root bridge. It's going to be elected root bridge. Also, I forgot to pretty much highlight which one we're using. So which STP we're using. Do show spanning tree mode, I believe. Do show spanning. Or we can let me see, because I believe we can show spanning. Let's use the question mark. Do spanning tree. Let's see something. Oops, I have to put let me try this one. Maybe this one will work. I'm trying to do it without looking at the book. I suck at show commands, by the way. All right, so let's do show run. Let's see which spanning tree we're using. I already know which one we're using. Wait, it showed it just like, okay, so we're using PVST, right? PVST stands for per VLAN spanning tree. When we initially learned spanning tree, we learned just regular STP, which only took into consideration one VLAN. Per VLAN spanning tree uses STP for each VLAN configured in the topology, right? And by the way, this is a basic topology. I didn't include all the other, secure layer 2 mitigation techniques and shutting down VLAN 1 and all of that stuff. This is just purely demonstrative. You want to make sure that you just understand we're just doing the STP and FHRP synchronization. So just thought I'd throw that out there at this point. We can also configure rapid PVST, rapid per VLAN spanning tree, which configures or activates rapid spanning tree, RSTP, for each VLAN instance, right? We can do that also. We're not gonna do that. We're just using regular STP for now, right? Just to demonstrate what we're doing, right? So let's go back. So we have for VLAN 10, root bridge, and for VLAN 20, excuse me, we have it as a root bridge also. Because this priority is obviously the lowest in VLAN 20, and by virtue of spanning tree, the election process, the election algorithm, it made it the root bridge. Now, the next thing we're gonna do is we're just gonna start configuring and verifying HSRP, right? So what we're gonna do is we're gonna go into VLAN 10, right? Standby version, right? So for the standby command, this is the command that we use for HSRP. And we have a plethora of options here. And we have IP, which enables HSRP and sets the virtual IP address. IPv6, we have an IPv6 version of HSRP. Preempt, overthrow lower priority active routers. Now, this is something that if I were you to pay attention to, you should understand preempt, right? Preemption. So OSPF talks about preemption. There's something else. STP. STP is preemptive. So OSPF is not preemptive. So if a designated router goes down in the preemption, if the designated router goes down in OSPF and it comes back up, it will not retake its spot as the designated router, right? So that's a little quirk with OSPF, but with HSRP, you can set a command, you can configure a command that'll allow it to overthrow the lower priority active routers, right? So, yeah, these are things to know, right? Priority sets a priority level, and based on the priority level, it'll either overthrow or it won't overthrow, as far as elect or not elect as the priority or the active router in HSRP, right? Of course, there's timers and hold times because the HSRP routers, these are the routers, even though they're layer 3 switch, but they also have routing capabilities. The hello and hold timers are essentially there for to aid in the routers keeping tabs on each other, right? Checking each other's statuses and making sure that both of them are, in working order, right? So if the active router doesn't send a hello message over a certain period of time, it'll converge and the standby router will eventually become the active router in HSRP. Priority tracking, I don't know what that is yet. Version, HSRP version. So we're gonna configure version 2. So we got standby version 2 now, and standby group 10. We're just using this as a naming convention so that we know that we're talking about VLAN 10, right? IP, this is a virtual IP, 192.168.10.254. I like to use the last IP address in the subnet, right? Right now, VLAN 10, group 10, state, init, right? It's giving you the status, right? It's activating. It activated HSRP as we see here. And then now we're going to do standby 10 priority 105, right? We set the priority. And then we're going to do standby. Oops. Let's see if I can finish it. Standby 10 preempt. There we go. Let me just make sure it's good, right? So now we see the state changes, right? It's similar to OSPF and EIGRP and these other routing protocols in the sense that the routers move from state to state. From speak, it went from init to init, speak to standby, standby to active, right? Boom. Now we're gonna go and configure it for VLAN 20. Standby version 2. Standby 20 IP 192.168.20.254. Right? We see it starting up. Standby 20 priority 95. Standby 20 priority preempt preempt. Boom, right? So now what we see here is that for VLAN 20, we set the priority to 95 because we want to ensure that D switch 2 will be the active router for VLAN 20, right? For the hosts in VLAN 20, right? So that's it for D switch 1. Now we're gonna move on to D switch 2, right? Let's click here. I'm just making sure you guys can see this stuff. Checking my OBS. All right. Now, the next thing we want to do, we're going to go to step 4. We're going to configure and verify D switch 2 as root for VLAN 20 and secondary for VLAN 10, right? So let's look at it. Do show spanning tree VLAN 10. And we can see here, there's no way this is going to be the root because we set the settings to ensure that D switch 1 is the root for VLAN 10, right? So now we see here, right? It's secondary, but we're still gonna do. First of all, let's look at the other one, right? It's not the root, right? So let's start configuring it. Spanning tree, VLAN 10, root, secondary, spanning tree 20, root, primary. Again, this ensures that this switch is going to be the root for VLAN 20, as we can see here, right? So now what we're gonna do is let's check up on it. Do show spanning tree, right? It's secondary, and then let's do 20. It's the root, right? Now we have to synchronize HSRP with it, right? And all we need to do is just go into VLAN 10. Standby version 2. Set the version for it, and then standby 10 IP 192.168. I need to double check the IP addresses up top for the other router. I just like to make sure that I got these dialed in, because if you screw one of these up, you're going to be troubleshooting. Priority 95, because remember, D switch 1 is going to be the active router, so we want to make sure that priority 95 is lower than the priority for D switch 1, right? So, and then we're going to do standby 10 preempt, right? Now we're going to do VLAN 20 standby version 2, and these versions, they all have to match. If they don't, then it's gonna get a little wonky, or it might not work. I think we could do a troubleshooting version of this video. 20254 activates it for VLAN 20. Now priority 105 to ensure that it's the active router. Standby priority. Standby 20. Oh my gosh. Yeah, let's just clean this up. I should have put the logging synchronous command on the console. Okay, so we should be good there, right? Also, I forgot to check. Let's go back. Let's start with D switch 1, right? Let's look at the show commands that we have available to us. So for the show command, we can do show standby brief. Let's expand this. So for VLAN 10, for group 10, you see the priority, right? It's the active router, local, right? And this is the virtual IP. So we see that we set this up. For VLAN 20, right? Or interface VLAN 20, we see that it is standby. And we see the IP address. So yeah, that should be all good. I think I configured it correctly. Yep, standby. Yeah, right? So that's how you configure and verify for HSRP on D-Switch 1. Let's do it here as well. D-Switch 2, do show standby brief. And we see here that for VLAN 10, it is the standby and you know the virtual IP, right? And for VLAN 20, it's active. It's the local router, right? And there you go. Virtual IP, everything is in order, right? Also, when you're setting a virtual IP for HSRP, any first hop redundancy protocol, you have to make sure that the virtual IP is in the same subnet as the hosts, right? For instance, let's save this. And you have to make sure that you set the virtual IP as the default gateway for the host. So we see that the default gateway is not the IP address of the actual interface for the router, right? It has to be the virtual IP of the, it has to be the virtual IP, right? So here we go. Show you something real quick. Do show run, because this is something that you have to know. So where's the okay, so we see for interface VLAN 10, right? It has this IP address right here, which is in the same subnet as all the other hosts in the VLAN, or the host in the VLAN in this case, right? But we're using the virtual IP of the HSRP group as the default gateway, because now when this goes down, right? Say we know that for VLAN 10, let me save this again. We know that for VLAN 10, D-Switch 1 is the root bridge, obviously, and it's the active router for this host in that VLAN, right? If this goes down, the virtual IP address will transfer over to this switch, and it'll still allow the host to communicate out to the internet, because it goes straight over to this router right here, which is why we have two virtual interfaces configured on this too, right? But these IP addresses doesn't really matter, right? What really matters is how it's done, and when a HSRP active router goes down, there's also a virtual MAC. I'm not even gonna get into all of that. Just read the book, right? And as a matter of fact, yeah, this is something that you should know on a basic level for the CCNA. It's in the exam objectives, but as far as the configuration, maybe, I don't know. Yeah. Just know how to configure this. I would say that. Just know how to configure this, because, yeah. Yeah, that's pretty much that though. So make sure you read through the book and understand these concepts. Again, the basics of it is that, let me mute that. The basics of it is that for FHRP, it allows for redundancy, right? And we're using HSRP in this case as our FHRP. Allows for redundancy, and then when you synchronize them together, it allows for a direct path out to the default gateway, and therefore out to the internet or any other subnet that it needs to communicate into, right? The host traffic. the general configuration principles is that you want to set that virtual IP as the host in whichever VLAN you're configuring it for as the default gateway. And that'll ensure that despite the fact that the active router goes down, that virtual IP address is still good, and it'll still allow for host traffic to reach its destination, granted that nothing else is wrong with the network, right? So that's pretty much it for this video. This one was actually short and sweet. Short and sweet is 30 minutes for me. She's still singing. I changed up the soundtrack a little bit a while back. I don't know how it's gonna sound, but hopefully you guys can hear me well, because my sound has been jacked up lately and I don't know what's going on. But I'm going to upload this packet tracer file to Google Drive, and you guys can download it and play around with it. It's not going to be pre-configured, but the answer is already here. I probably ruined it for you. I would say just try to replicate the lab without looking at the answers. That's how I learned. I would go from lab to lab, resource to resource, and just try to replicate the labs without looking. And that's how I got really, I would say, I don't want to say proficient. I would say I'm at an intermediate level, low proficient in configurations, because I made sure that I understood what I was doing, right? I forgot this guy, I forgot his name. Kevin Wallace, right? He just posted something that said something to the effect of how to approach Cisco exams. It's basically focusing on doing to understand the concepts and not just reading for theoreticals. And you can understand the theory, that's great, but if you don't know how to take that theory and apply it, that's something that you're gonna suffer with. And this applies to me too. This is why I'm labbing as much as I can every week, or every day. I try to lab every day. But now that I'm working, it might be somewhere, I would say every 2 to 3 days, every 3 days, to keep my skills fresh. And then I do things like this, right? As I'm writing this stuff out and writing it from memory, looking at resources like Jeremy's IT lab and coming up with the subnetting plans. Well, it's not much of a plan here. It helps to solidify the information, and it helps to enable me to consistently practice it in a functional way, right? Because again, you would hate to become a paper CCNA or a paper certified individual. You need to figure out a way to be as useful and valuable to employers as possible. At least that's the way that I see it, right? So that's pretty much it. I'm going to wrap this up, and I will see you guys in the next video. Peace.